questions? Oh, you have the question?
Yep. Very nice. In the phase space diagram, the globular clusters, are all of those bound or are some of them not bound anymore?
So this is at least colored so that you could see the substructures. And maybe you can't see it from where you're at. And I apologize for that. So the dwarf GCs are out right here. They're all on top of each other. You can see these orange ones are associated with this orange cloud here. I don't know. Maybe you're asking about these systems here. I haven't looked in detail, but I think in general they're bound. Yeah.
It'd be interesting if some are no longer bound or being kicked out. Or...
Yeah. I mean, it's close enough to the systemic velocity of Sen-A that I haven't thought about it. Yeah.
So you mentioned some of these globular clusters have proper motions in Gaia. And so clearly they are not globular clusters, they are foreground stars. So why were they classified as globular clusters previously?
Well, because they have colors similar to globular clusters. And people took spectroscopy of them, and they had velocities that were 200, 300, 400 kilometers per second, maybe with large error bars, but still, and that's consistent with Sen-A's halo. So they took the fact that the colors were pretty good, plus the velocity was pretty good, and they called it confirmed. Maybe you don't remember the world before Gaia. Yeah.
Maybe let's take another question while we set up the next speaker.
Okay.
So that was a nice ode to your student, Dave. Well done.
Oh, thank you.
So, this is sort of looking to the future. I mean, you've emphasized the Gaia proper motion as part of the filter function, but I think I don't know if there's an LSST expert in here. Bob's not here, but I thought LSST was actually going to get to similar to what Gaia can do, several magnitudes deeper. Does anybody know if that's true? Because that would then extend things, Dave, further out, right? And that would be just increase the number of galaxies you could do this technique on.
If true, that sounds great. I don't pretend to know what LSST promises.
Yeah. Okay. I don't know. Does anybody know? Yeah. Canute.
I think you can get proper motions in the Milky Way halo. Sorry. In the Milky Way halo, you could get proper motions out to, I want to say, a couple hundred kiloparsecs. With LSST, and of course, go faint, right? But it's not going to do as well as Gaia can do. But using this technique, yeah, I guess maybe should think about it.
Yeah. Okay. Fair enough. Thanks.
Okay, well, let's thank Dave again.